Okay, this is section 5.4, part 2. Part 1, if you'll remember, our new derivatives, we're finding the derivatives of e to the x or e to the u, and it was easy. We liked them because the derivative was just e to the x or e to the u times the derivative of u. So now we're going to go backwards and we're finding the antiderivative, and it would just make sense that when I'm integrating e to the x, my answer is going to be e to the x. And then since this is an indefinite integral, I need my plus c. Or if I'm integrating e to anything other than x, we're going to say that's e to the u, and that's going to be e to the u times the derivative of u plus c. Okay, so we're going to do example 1 together. Okay, in this problem, I have e to the something other than just an x. So I'm going to use u substitution for this. My u would be my 3x plus 1. And remember, anytime we write down a u, I have to find the derivative of u. So the derivative of that u would be 3. So remember, here's my u. I need to make sure my derivative is also in the problem, make sure everything matches up, and it doesn't. I'm missing a 3. So I can put my 3 here as long as I put my 1/3 out in front. Okay, so now I have the problem 1/3. That 3 is my du, so I'm not going to rewrite it. And then I would write e to the u du. And now I'm going to integrate. This constant's just going to stay there. The integral of e to the u is e to the u plus c. And then I need to substitute my u back in. 1/3 e to the 3x plus 1 plus c. That's my answer. Okay, so let's look at example 2. Now example 2, my computer wouldn't let me fix this. This is actually negative x squared. It wouldn't let me put an exponent on an exponent. Okay, so really here's my problem. 5x e to the negative x squared dx. Okay, and in these problems today, your hint is your u is usually going to be your exponent that's above your e. Okay, so let's write down our e and our u and our du. So if my u is negative x squared, that means my du is negative 2x. Okay, so like here's my u. I need to make sure my du matches up. Well, it doesn't. My x is there, so I'm good with that. But this 5 is messing me up. That's supposed to be a negative 2. So look, we can take that 5 out in front. So now my 5 is gone. But I still need a negative 2 there. So I can put my negative 2, but if I put a negative 2 there, I need a negative 1/2 out in front. So if I put a negative 1/2 out in front and I already have a 5 there, that's going to change this to negative 5/2. So I have my negative 5/2. Okay, here's my du, negative 2x. So I'm going to rewrite the problem as e to the u du. Now we're ready to integrate. So I have my negative 5/2. When I integrate e to the u, it's just e to the u plus c. And then I substitute my u back in. Negative 5/2 e to the negative x squared plus c. Okay, so far so good. Example 3. All right, so our hint usually is to let my u be my exponent above the e. So if u is cosine x, then du, the derivative of cosine, is negative sine x. Okay, so here's my u. Here's my du, but it's missing the negative, so I can put the negative here as long as I put it on the outside. So now I'm ready to rewrite the problem. My problem now is negative, oops, not sine, let me get rid of that, Okay, negative the integral, that's my du. I have e to the u du. So now I'm ready to integrate. So I have negative integration of e to the u is e to the u plus c. So I have negative e to the cosine x plus c. Okay, example 4. All right, I'm going to try and let my u be 1 over x. So I have u equals 1 over x. And I'm supposed to find the derivative of 1 over x. So remember, if I want to find the derivative of this, I need to move this up to the top. So now I have x negative 1. So now the derivative of this would be bring down my exponent, subtract 1. So really, the du is negative 1 over x squared. So do I have negative 1 over x squared? Remember, this is my u. I'm looking for du. I have 1 over x squared. It's just not negative. So I can make it negative, negative. Okay, so let's look and make sure everything matches up. All right, here's my du. Here's my u. So my integral now is negative e to the u du. This is my du. Here's my e to the u. So the integral would be, when I integrate, negative e to the u plus c. Substitute your u back in, negative e to the 1 over x plus c. Okay, example 5. Okay, now we have definite integrals. So before we just put plus c, now we have to actually plug our numbers in. So same thing, if my u is negative x, du is negative 1. So I need a negative out here. So now I have negative e to the u du. Now remember, if we use u's, if we use u's, we have to change our upper and lower numbers. So no longer in terms of x's. So I'm going to find u of 1. So that's e to the negative 1, or 1 over e. When I plug 0 in, and I'm plugging them into this right here. Oh, that's not right. My u is negative x. So when I plug 1 in, I get negative 1. When I plug 0 in, I get 0. So look what happens. I have negative 1 here and 0 here. So remember what happens if I have my lowest number on top? I can switch these, put my negative 1 here and my 0 here, but when I switch them, I have to change the sign of this. So now it's positive, e to the u. Okay, so now I integrate. It's e to the u, negative 1 to 0, e to the 0 minus e to the negative 1. I'm plugging my numbers into my u. So e to the 0 is 1 minus 1 over e. Example 6. Okay, on this one, I'm not going to let my u be my x. Okay, this time I'm going to let my u be 1 plus e to the x, because look what happens. When I take the derivative of this, derivative 1 is 0. The derivative of e to the x is e to the x, and that matches up. So look, here's what I have. U, there's my du. So I'm going to rewrite the problem. That's going to be du, or 1 over u du. Let's change our upper and lower limits. So when I plug 1 in into my u, I get 1 plus e to the first. So this is going to change to 1 plus e to the first. When I plug 0 in, I get 1 plus e to the 0, which gives me 1 plus e to the 0 is 1. So that's going to be 2. Now we have to make sure that 2 is smaller than this. This is 1 plus 2.7 something, so it is. So now I have to integrate. When I integrate 1 over u, I get natural log of absolute value of u. And I'm plugging in 2 and 1 plus e. So remember, when I change my upper and lower limits, I don't have to substitute my u back in. So now I have natural log of 1 plus e. I don't have to put my absolute value bars around this because this is automatically positive, minus my natural log of 2. So you can leave it just like that, or if you put that in your calculator, you should get 0.620. Okay, last example. Okay, on this one, here's my u. Okay, example 7. This is my u. Okay, so if u is e to the x, derivative of that is also e to the x. So everything matches that. That's good. Here's my u, here's my du. So I'm going to have the integral cosine u, here's my du. So I need to find my new upper and lower limits. So I'm going to plug in 0 for my u. So e to the 0, and anything to the 0 power is 1. So my new upper limit is 1. I'm now going to plug in negative 1. So when I plug in negative 1, I get e to the negative 1. You can leave it like that, or I always write it as 1 over e. So now I'm ready to integrate. Okay, so when I integrate cosine u is sine u from 1 to 1 over e. So I have sine 1 minus sine of 1 over e. You can leave your answer just like that. Or if you put it in your calculator, you would get 0.482. And make sure, remember, anytime you're in calculus class, your calculator should be in radian mode. Okay? All right, that is it.